Hello, everybody, and welcome to Echo number 7. This is Duffie. Um, I'm really looking forward to this. This is my first Echo. It's my first live stream from the from as part of Cilium. So I've just joined Isovalent about 2 weeks ago, and these last 2 weeks I've just been sponging the data into my brain as fast as I can, learning everything I can about everything. And it's always a great experience. It's definitely one of those lifelong learner kind of things. I spend a lot of my time learning and relearning and helping other people learn everything about, technology, systems, all kinds of stuff. You might know me from the TGIK.io series. I worked on that project while I was at Heptio and at VMware, and I'm really looking forward to kind of continuing a similar vein here at Isovalent. So I'm really looking forward to that. Let's see who's with us today. So let's see who's with us today. So today we got Michael Mullen saying hello. How you doing, Michael? And Rory. I thank you, Rory, for not saying where you're from because I can never really pronounce that. It's like Lagoyle Head or something like that. Pretty cool in Scotland. Noel, good to see you. Russell saying hello. We got a meme +1 for grokking Cilium. Yeah, that's what I am here for. I think this is what I want to kind of make my part of the episode series is like grokking Cilium, but I feel like we can do more than that, right? I feel like we can really kind of get into some of the more interesting use cases that people run into in the networking and security space, and I would love to dig more into that. That's a great point. Neela, good to see you. Neela is going to be helping me inside the chat. You want to kind of help moderate that sort of stuff. We have Garcia saying hello from England and Zolt from Finland. We have Biz from the Philippines. It's great to see you all. It's really good to be here with you. So let's get into this. So what we have, I've gone ahead and created a HackMD for this episode, and we'll probably start doing something very similar. There's going to be a lot of crossover between what I did at TGIK and the way that I host these sorts of episodes. And that's because I think that, there's a lot of stuff that we kind of discovered during TGIK that really works really well in these cases. And so I definitely want to take what I've learned and apply it here. Hey, Chaco, good to see you. And Hameth, hello from Jersey City. Good to see you as well. So this, I put the link into the chat. You should be able to see it in the Slack here. And I've just linked it to the @Maui Lion organization. I still have to set one up for Echo, but it'll probably be a hackmd.io/@echo or some such like that. So probably next week we'll have that set up. But this is what we're planning on covering this week. I'm going to start with some headlines and stuff. And actually, Antonio, who might be here or who might be joining, I haven't seen him yet, actually shared something on Twitter, which I thought was actually pretty cool. So if you're interested in kind of just playing with or becoming a little bit more familiar with what eBPF and those sorts of things are, this is a great series. I mean, this is going to be a great episode for you, and it's also going to be a great episode to it's also going to be a great show kind of ongoing. My plan is to really try and use this as a platform to really help people understand what eBPF is and how it applies to so many different aspects of platform technology and that sort of stuff. So let's take a look at the thing that Antonio put up. This is pretty cool stuff. Apparently, Antonio was running into a problem that I'm sure all of us can kind of resonate with, wherein he was trying to prove that the problem was IP tables. And the situation is how do you prove that, right? You could turn IP tables off, but maybe that's not the right thing. So you're just trying to prove that you could either establish a connection or not by bypassing IP tables. And leveraging BPF is a way to do that. Because you can bypass IP tables and make the connectivity and make the connection between your BPF program or you can make the connection directly to whatever your target application is, perhaps even within a network namespace, and bypass IP tables and prove that you can connect to it without IP tables, and so the problem must be IP tables. It's kind of like the network engineer's version of It's Always DNS, although I suppose that is also the network engineer's version of It's Always stuff, But yeah, good stuff. Good to see you, Rich. Welcome. And Rio from and the Netherlands. Good to see you. So yeah, I mean, I know Antonio from the Kind community, and he's a very kind individual, and you should definitely check this out if you want to play with it. He's got a pretty good setup here to kind of play with how this works. It's a Go binary. Yeah, if you want to explore that and play with it. He's also written some tests, which I thought were pretty cool. So there's definitely some good output in the tests to kind of like show how this process works, like what he's actually thinking people could use it for. I do kind of love looking at tests for that sort of action. I hope everybody can hear me okay. I haven't really checked my mic, but it seems like people would have told me by now if they couldn't hear me. This is probably too small also. All right. So that's the first one. We also have a really good article by Jonathan Corbett that talks about another problem in the kind of the community, and I've explored this one a little bit as well. Seccomp, as it was written, doesn't leverage eBPF. Seccomp, as it was written, and Seccomp, for those who don't know what Seccomp is, it's tooling that allows you to limit the system calls a given process can make. And we have implemented this in Kubernetes. There's ways to actually create Seccomp profiles and to actually do some discovery around the way that Seccomp profiles work. But as we move into more like container orchestration models and that sort of and these sorts of systems, it becomes really handy and really neat to be able to limit what those sorts of systems can do from a syscall perspective, like what kind of files can they open, what sort of network connections can they make, and those sorts of things. And Seccomp gives us a way to do that. It's not the only way, but it's certainly a way to go ahead and create a profile that encapsulates what you think is normal for that application, and then to be able to deny any sorts of activity that that application might make. Now, there's a couple of different challenges with Seccomp, and if you're curious to learn more, I actually I did a talk on Seccomp. It was like a jungle guide to Seccomp at San Diego KubeCon, I think it was, maybe in the security days. But I'll put a link to that in the HackMD later. But some of the challenges with Seccomp is that because it was written in a way that was before eBPF, the extended Berkeley profile existed, it's very limited in a lot of the tooling that it can actually use to go ahead and make those filters. And so there have been a number of attempts. In this article, they actually call out a number of those attempts to basically port the Seccomp capability on top of eBPF and kind of open that door and allow a lot more of the capability to be used there. But it hasn't been successful yet, because the extended Berkeley protocol the extended Berkeley packet filter gives us quite a lot of capability in the kernel to like compile applications that do all kinds of or eBPF programs that do all kinds of interesting things at pretty much any layer. I mean, across a very wide surface within the Linux kernel, and Seccomp traditionally did not do that. It was not, you couldn't write like C and compile that into a Seccomp profile. You were very restricted in the specific domain language that Seccomp profiles would allow. So with this change, I think this particular implementation is trying to make it so that we maintain that same strict order. Like you're still not going to be able to leverage Seccomp to compile. You're still not going to be able to leverage this technology to compile like custom C programs and drop them into the kernel and manage things. The goal is to just basically move the implementation of Seccomp onto eBPF so that we can make that a bit more efficient and also leverage some of the technologies that extended the eBPF mechanisms actually expose. So pretty cool article if you're into that kind of thing. There's also been, out of this article, I learned about Easy Seccomp, which is something I had never seen before, which is a domain-specific language for defining Seccomp profiles. This is actually pretty cool. I wish I'd known about this when I did the guide, because it actually does a pretty interesting set of tools for generating Seccomp profiles. I think that you can't really say eBPF and not say Brendan Gregg. Like, he's spent a lot of his time out there talking about what's happening here and written a number of really incredible books and tools on how to actually leverage BPF to do performance profiling. And so I think Usenix was either just, yeah, so this was just published on the 2nd. And these were presentations at the Usenix conference. And so if you're curious to see what Brendan's talking about this time around, definitely check it out. He talks about computing performance on the horizon. There's a BPF internals talk, which I think was really good. And then there's actually another one, not by Brendan, but by Zachary Jones at Verizon Media, which I read, and I definitely recommend if you're interested in this BPF space. I have an audio problem? Does it mean that you can't hear me? Oh, in mono. Okay. Interesting. Let's see if I can figure that out real quick. Analog. Okay. I'm not sure that I'll be able to adjust the stereo-ness of it. Advanced audio properties? What if I go like that? Is that any better? How about that? So this could be stereo now. Is this stereo check? Stereo check? It looks like on the graph on my side, it looks like I've got them pretty equalized. But I wanted to make sure that you all see a pretty good equal connection. So, oh good, awesome. All right, cool. Now balanced but quieter. So now I'm going to turn the volume up a little bit, and it should not be as quiet as it was. Thank you all for letting me know. I'll dig into what's happening there. That is kind of weird. I have a stereo microphone, so I wonder if one side is dead. Anyway, perfect, awesome. Thank you for the feedback. I mean, not feedback, but I appreciate it. The freedom of Linux, the prison of Pulse Audio. Although I haven't played with it yet, but I was looking at Pipewire, and I'm not sure if that's a better solution or not. Carlos, good to see you. All right. So this one also was a really good article, and if you want to check out the slides for this one, I think they actually have an incredible presentation here that is definitely worth checking out. Like I really got a lot out of this one, and some of my my favorite content in this one was he actually quotes Brendan Gregg a few times. I really love this one right here. Before this point, I was doing what Gregg calls casual benchmarking. You benchmark A, you actually measure B, and you conclude that you've measured C. And I love that. Like, it's like such a perfect example. Good to see you, Christopher. Good to see you, Marino. Yeah, so like, he also gets into some really interesting like systems level stuff, like time accounting. Like if you're going to do performance measuring and try and understand like how much CPU time it's taking for particular things to happen. And it actually gets into this in, let's see, where was it at? Probably up here. Oh yeah. He calls out this point of it, right? When he was doing an XDB test, which is basically, you know, accelerating a packet through the system. He like wired up the configuration, compiled a BPF program, and then put traffic through it. And he saw that the CPU, the soft IRQ CPU utilization across the XDB path was like almost nothing compared to everything else, right? And was like, well, that's like so low that it can't possibly be real, right? Like how is it possible that it's real? And then goes on an incredible journey of basically trying to determine why that's not real, right? And so I thought this was an incredible article. I definitely really enjoyed it. So definitely check this out if this is where you're at and what you're interested in. We might kind of explore we might kind of get into performance exploration stuff here on this show. Probably not today, but like at some point, I think it would be kind of a fun one to kind of dig into that. Maybe we can pull somebody from the performance team and dig into this. The next thing I wanted to tell you, this is my special announcement. I'm going to be doing a couple of different video podcasts, including a Twitch stream that's going to kick off on Monday. This coming, I don't think I'll be in the first one. I think the first one's going to be handled by Kat and by with a good friend. And this is actually going to be hosted on the Twitch stream. So if you go to cloudnative.tv on Twitch, you'll be able to see all of these episodes. And there is a lot of content coming. Tim Banks is the other person who's going to host the first one. So these these shows will actually dig into a lot of really great content. And so if you're here for the Kubernetes side of things or for the CNCF kind of ecosystem or environment, these talks are going to be incredible. And I am going to be hosting this one moving forward. So not this first episode, but after that, I'll be hosting this one every week. And there I'll be doing the latest news from the cloud native community, very similar to kind of like the opening of TGIK, just talking about what's happening in this space, talking about what's going on in cloud native communities, and then also kind of playing around with some new thing or something that has caught my eye. And likely there may be some overlap between like the eBPF stuff and what's catching my eye, because that's going to be kind of my focus for the next couple of years at least. But let's look at what else is coming. There is so much other great stuff coming. We have 100 Days Cloud Native with NIS Ulrich. We have Cloud Native Classroom. I'm really looking forward to this one with Kat Cosgrove. And this is where Kat gets somebody in a room and says, okay, now explain this to me like I'm 5. Like, I'm going to ask you all the questions, and I want you to really help me understand like how this technology works and how it is actually a good thing. We got Fields Tested with Caslin Fields, which I think will be really fun. And David McKay helping people become better contributors. You know, like, and that's David right there in our chat. So David's going to be talking about like, you know, you see a project that you want to contribute to, how do you even begin? Like, how does that process work? And like, how can you become, and how can you kind of move your way up that ladder, right? Like if you're, from your first contribution, maybe it's docs, maybe it's opening an issue, maybe it's like helping somebody else who's already opened an issue, all the way up to like, how do you become a maintainer? Maybe that kind of stuff. We'll see how it goes. I'm really looking forward to checking that out. We got Spotlight Live with Dan Pop. If you haven't seen Dan's shows, they're incredible. He's just such an incredible human, and it's always great to watch those things. And we have Solid State with Tim Banks talking about BIPOC and LGBTQ situations inside of tech, and like kind of talking about the struggles and the challenges in those environments. I think it's really important that we hear those things and that we like really connect and help make those things better, you know. And so, how can we make them better if we can't see them? I hope that this sort of an episode will help kind of like open that up. That'll be really great. Cloud Native Latinx with Leonardo Murillo, somebody I just met at this last KubeCon. We have a CNCF face-off from Matt Stratton, and then Certs Magic with Siam. Siam has actually done a lot of work on helping people feel more comfortable taking the CKA and the CKAD, also with the CKS. So if you're interested in actually like taking the certified Kubernetes certification, definitely check these out. There's a lot of really great content coming, and I'll be hosting one of them. So definitely check it out. I mean, definitely see some of, take the time to check out some of that content. I think it'll be great. So let's get into the fun stuff. So today I was going to be hosting Thomas Graf in this episode, but Thomas had something else come up, and he was not able to join me in this episode. I think I will host him again, perhaps in the next episode, and dig into that with him. But today you're just going to get me. It's going to be TGIK style, solo Duffie, interacting with the chat, that kind of stuff. So there's a couple of interesting things we could talk about for the first bit of it here. I'm going to go ahead and play through some of the quick installation guides. If you haven't already done this with Cilium, that it might be worth playing with, or it might be useful or not useful, but that's what I'm going to be doing. Definitely check it out. You want to do it with no kubeproxy? We can play with that. So, because Cilium operates at the kernel layer, actually let me kick back to this section. So because Cilium operates at like the kernel layer, that means that when you use technology that shares a kernel across nodes, that you might get, you're somewhat limited in the feature set or capability of Cilium there, right? Because Cilium's goal is to basically allow for routing and security and observability and all of those things that happen at the kernel layer between your processes running inside of those containers and that kernel layer. And when we kind of change the world on Cilium and we say, like, look, there's only just the one kernel, everybody's on the same kernel, and what's happening at the node layer is going to be also, further abstracted into processes or into containers. And this is the reason why I've been leveraging Minikube to actually run the tests. Because I know that with Minikube, I can actually now, as of a recent version of kernel, actually not super recent, but as of a relatively recent Minikube, you can create multi-node clusters. And we're going to play with that. So you can create multi-node clusters with Minikube. Minikube leverages kubeadm under the covers, so we can do stuff like skip phase, add on kube proxy, and we can actually make a kube proxyless kubeadm configuration. There's a lot of different options that we can actually do it. So I'm actually probably going to go back and forth. I'm still playing with kind myself a lot, but because I'm actually playing with the technology that operates at the kernel layer, I'm also playing a bit with environments in which each of my nodes can have their very own Linux kernel. And I played with a few of these this last week. I played with a thing called KubeFire, which allows me to leverage Firecracker VMs for this. I played a bit with Footloose. I played a bit with a number of different, obviously Vagrant environments and those sorts of things. But we're probably going to go back and forth. How you doing, Sevi? Good to see you. Noel saying, "Where's Waleed?" I know Waleed would be great. It'd be good to see. Be good to see Waleed. All right, good to see you all. All right, so let's get this kicked off. Let's go ahead and create our Minikube. Maybe what we'll do is we'll create a Minikube cluster and we'll create a kind cluster and we'll kind of look back and forth between the two different environments. But let's do the Minikube one and see what that looks like. So one of the other things I learned is that you can actually create a Minikube cluster with Cilium already installed if you do it with a relatively delete -p. If you create if you start with a recent version of Minikube, you can actually pick different CNIs that you want implemented already. And the way that that happens is that it leverages like a quick start YAML that was in the Cilium repository for a while, and I need to actually look into why that's no longer there. So that's one of the things on my list of things to look into. But what this lets us do is we can create just a Minikube configuration. We'll call it cluster 1. This is using the Cilium CNI, and it's going to run with 3 nodes. Now what I'm going to do here to play with the Cilium CLI is I'm going to use the Cilium CLI to effectively uninstall that deployment and install again the newest version of Cilium. And then we'll play with like how that works and like what kind of things we can do with the Cilium CLI, which is pretty neat. While that's booting up, let's head back over here. It is a Riced i3, I'll give you that. Yeah. I was actually thinking about doing Plasma in i3, but I haven't actually spent the time to play with it yet. Oh, the old trick. Yeah, it's true. I totally did do that, didn't I? All right, so there's my Minikube start profile C1, CNI Cilium, nodes 3. And this is going to create 3 nodes on my configuration. Make that a little bigger. There we go. And this is going to be with kube proxy, but we could also deploy it without kube proxy, and so we'll play with that as well. But first we're going to go ahead and kick it off like this. Thank you. Hey Joy, good to see you. So again, while this is booting up, I kind of want to go back over here and look at how this works. So we've gone ahead and we've created our Minikube cluster, And then it talks about how to grab the Cilium CLI. And this is basically just grabbing the latest version of the Cilium CLI from the release page on the Cilium CLI project. So if you are interested in opening issues or playing with Cilium CLI, we'd love the feedback. Those issues can be opened in this issues page here. If you want to grab the latest release, you can just go to the releases tab, and it's built for Darwin, Linux, and ARM. ARM AMD 386, that's an interesting. And also Darwin. So this means you can run it on your Mac Mini with your ARM Mac Mini and that kind of stuff. Pretty cool. Awesome. All right, so I've already grabbed the Cilium CLI, but if you want to follow along at home, if you want to go ahead and kick up your own Minikube cluster and grab the Cilium CLI from here, you can do that. And then what I'm going to do is I'm going to do a Cilium install myself. What was the question here? Let's see. So Carlos is saying, you can replace keyproxy with Cilium. Yes, you can. But certain features of that require specific kernel versions. A link to where that would go would be kind of interesting. Right? I know, I was kind of surprised by that too. Magno! Good to see you. All right. So let's see where we're at with our cluster here. Still spinning up the other two nodes. Yeah, Carlos, I think that particular question has actually definitely changed over time because as the entire kernel moved forward, I mean, one of the things that really caught my eye about Isovalent was that like it's a 4-year-old company, and I would say that probably 3 of those years were spent getting the kernel ready for where we are today, right? So like we have incredible contributors to the Linux kernel who focus on eBPF all the and that whole space, and they've been moving the kernel forward into a place where it can actually support a lot of the technology that we've been building with Cilium going forward. So I think if I remember correctly, it's like a 4.15 or 4.19 kernel is the minimum, but I'm sure that Chris could correct me if I'm way off target there. Chris is one of Chris is one of the solutions architects here at Isovalent, and I've learned a ton from Chris already. Like, just even getting my brain around like where the company is and like what we do and all of that stuff. Chris has been just hugely beneficial, hugely helpful to me. 4.9, that's what it was. Okay. And you want the shiny new stuff? It's 4.19 or later. The shiny new stuff being, no Windows nodes when using Cilium. I don't know. I don't think so. Good question. Thank you, Rory. Perfect. Thank you, Chris. That's awesome. All right. So we got our cluster up. Let's do Cilium, because I've already installed the Cilium binary. Let's do Cilium status. I know I'm like following along in the chat. And we can see what we've got deployed here is version 1.8.0. And that's a pretty old version. We have a Cilium operator and the Cilium binaries here. So what I'm going to do is I'm going to do a Cilium uninstall. And what this will do is wipe the network. It'll wipe the CNI completely off of the cluster. And then the next thing I'm going to do is I can go ahead and do kubectl get pods -a. You can see that they're all gone. And then I'm going to do Cilium install. Version v1.10.0. And this is going to install the latest version of Cilium on the host. It's also going to generate some certificates. It's doing a lot of the certificate generation stuff so that we can encrypt the communication back and forth between different components of the architecture. So while that's happening, let's go back and see where we are in the generic startup docs here. So we've got our Cilium, we've just done our Cilium install. I specified a version, and they actually call out here the requirements. Kubernetes must be configured to use CNI, which has already been done for us. And the Linux kernel is a 4917 or later. And we see a bunch of information here, including this bit here, which I thought was actually kind of, you know what, let me make this a little bigger. I think I ran into the same problem. Oh, other bigger. All right, there we go. That's probably better. So I saw this in a previous configuration because I already had like some other applications created inside of my Kubernetes cluster before I installed Cilium. And what happens is it does a thing where it goes ahead and it restarts any unmanaged pod. And I want to talk a little bit about what that means and how that works. But we're going to get into that here in just a little bit. Once we have Cilium install running or completed, which is I think where we are, we're going to do a validate the installation. So we'll do that. Let's see where we're at with this. kubectl. Image pull back off. What? Did I mess something up? V1100. That's cool. Why is that happening? What's interesting is, you know, does anybody else want to say it, or does anybody want me to say it? I can tell you, like, what I think is happening here. Remember, does anybody else want to just shout it out here? It's always DNS. Exactly. All right. Why is it DNS though? It should not be DNS. iptables. What is that? Why is forward drop? Man, well, where to go from here? Let's see. Well, let's just prove what we got going on here. So, minikube SSH minus P C1 IP ping google.com. Yep, that's the problem. Cat resolve.com 10023 IP route. Oh, ha 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 ha. All right, it's not DNS. I mean, it is DNS, but it's not DNS. So that's pretty fun. IP link link or IP adder. So we have an overlap of IP addresses because we are in a VirtualBox configuration. We have this as our NAT interface, 10.02.15/24. So that is the VirtualBox interface that lets us NAT out to the world. The problem is that, I mean, that's fine, right? But when we installed Cilium, and that second node kicked up, that's where we actually configured that. We configured it in such a way that we were giving out that same IP address, and then in the underlying routing table, we are now actually sending our DNS traffic to a host that may or may not exist at 10.02. What is it? 10.02.12 or whatever it is. Cat. Let's see, resolve.com. 10.023. So we're sending that 10.023 traffic off to this off over the Cilium network to another host that is not going to be able to answer DNS. So I think what we can do here is let's go ahead and see if we can figure out how to fix this. So let's do Cilium uninstall. And then we'll do our Cilium install again, and we'll look at the other options that we have. It's not about core DNS, actually. It's about routing. Yeah, I want to change the subnet. So what I want to see is how we can go ahead and do that. I want to give it a different subnet. I'm installing Cilium at least 3 times. I'm crazy. IPAM string, maybe? It's layer 9. Oh, I thought you said layer 3. I thought you said layer 9, which I thought was going to be hilarious. Or layer 8 or whatever. Cilium. Subnet. How do I change this subnet? It's probably not where I want to be. Yeah, I think there is a way to use the native IPAM. But I kind of don't want to use the native IPAM. I want to use Cilium install. Fast installation. There's got to be a way to actually configure this. No. Yeah, that would work. They wouldn't overlap. Joe's idea was not sure which IPAM mode it's using by default, but could maybe use Kubernetes IPAM and then use annotations on the node resources to control which ranges are used. I'm actually looking for the CIDR that the pods are going to be allocated from. I'm trying to do a Cilium install, or it's probably like a -- config option, but I'm looking for a way to change the CIDR that Cilium assumes for the cluster by default. It is a Cilium CRD, but there's a way probably to populate that at install time. I think what I'm going to do is I'm going to do this. So I'm going to do, let's take a look at Cilium install. Yeah, I think so. I just received a link. Let's go ahead and take a look at that one. Paste. So under concepts networking, Kubernetes host scope. The Kubernetes host scope IPAM mode is enabled with IPAM Kubernetes and it delegates the address allocation to each individual node in the cluster. IPs are allocated out of the pod CIDR range associated with each node in Kubernetes. In this mode, the Cilium agent will wait to start up until the pod CIDR range is made available to Kubernetes to be one node. All right, well, that's one way to do it because then we can actually configure, we can specify, or we can allow for Minikube, or the Minikube to go ahead and set that configuration. So let's go ahead and look at this. So that might be the way we get out of this. So let's try this out. So if we do kubectl describe node C1, we can see the pod CIDR allocated here was 10244, and there's no overlap there, so that would actually work. So it's using the default pod CIDR that Kubernetes ships with, and then in Cilium, we can see there's our overlapping piece of it, right? So let's go ahead and try that out. So because I think I've already done the uninstall. Kubectl get pods -a. Yeah. So then we'll do our install again. IPAM. Equals Kubernetes. What I was trying to do is figure out that second one, because I figured there's probably a way, probably through the -- config option, to specify what the pod CIDR is that I want Cilium to use. In this method, what I'm doing is I'm going ahead and allowing for the controller manager to annotate each node and handle the IPAM for the IP allocation to each individual node, and then Cilium will just inherit that from the IPAM configuration. But what I wanted to do was change the default, the pod CIDR that Cilium would use and fix it that way. But I wasn't able to get there. Get pods -a. Oh, you know what? We're still broken because of that problem. So I'm going to do Minikube delete -p C1. Control R, Minikube start. All of this is happening because I created more than one node. Isn't that great? Isn't that crazy? But Does everybody understand like the routing problem that we had? This is an interesting challenge. I mean, and it's one of those things you're going to run into because the Linux kernel's routing table is like effectively the way that it will route packets. Um, we have to be kind of really careful about overlaps, right? And so what happened here was that I'm using VirtualBox as the virtualization component here. So when I create new virtual machines, I'm using VirtualBox for it. And if I pop open VirtualBox, I want to kind of show this. C5. So here's my first cluster that's coming up. And what I wanted to show you here real quick was kind of like what's happening or how that node is configured. So that node is configured with two different interfaces. The adapter 1, which is a NAT adapter, and the adapter 2, which is a host-only adapter associated with a host-only network called VBoxNet 5. When the nodes are intercommunicating, right? It's like when the worker node is interacting with the control plane node over the Kubernetes API, it's going to use that VBoxNet 5 network to do it. But adapter 1 is actually going to look the same on every single node. So if I jump into each individual node, they're all going to be addressed the same, and they're all going to have the same DNS, and we're using that NAT network to handle the DNS resolution. So our problem was that because the NAT interface is configured for 10.02, and that means that the DNS IP address that we're going to be using for DNS, the DNS server, is going to be 10.023. And when we create multiple nodes and configure Cilium CLI for all of these things, I wonder if we'll still be messed up. Anyway, when we configure the Cilium CLI for these things, what happens is that the Cilium CLI, the Cilium CLI will configure we'll configure a subnet for each. We'll configure a subnet and allocate that subnet for each node in your Kubernetes cluster. And on the underlying routing table, it will create a route so that we can attract the pod CIDR, we can attract that pod traffic that is associated with one of those nodes to that node. The problem is that we basically had two routes, one route going toward NAT and one route going toward the other node. And what happened there was we basically ended up in a state where we were sending our DNS traffic to another worker node. And that other worker node was like, I don't know what to do with this DNS traffic. Get it out of here. Like, I'm not answering that call. We might still be in the same situation again, and it might be interesting to find out. So let's do minikube SSH minus P C1 IP route. Yeah, it's going to be this. No, it's not the same yet. Well, yeah, we're okay. We're okay so far. We're probably not going to make it though, because I imagine that this route right here is going to get overwritten as soon as that second node comes on. So as soon as this is done booting up, we're going to see that happen. See, right now this is exactly what I was looking for on the host side. This route is sending 10.020/24, and it's sending it to it's sending it out ETH0, and ETH0 link show is that interface that's connected to the NAT. So now that all three are up, hey-o, there's our problem. So you just basically overwritten the route that was here before, this one. Oh, where'd it go? There we go. So this was our old route, and we can see the route is headed toward, our source is 10.0.2.15, but we're sending that traffic out the ETH0 device, And our new route that conflicts and overwrites that route is sending all of that traffic via 10.0.0.12 out a Cilium host device, which means that it's basically sending it encapsulated with whatever form of encapsulation we're using to that other host. Isn't that wild? Could we create a higher route? Yes, we could. There's lots of different ways to solve this problem. Likely what would happen though, see, I imagine that, let's look into this a little bit more. We could fix the DNS problem. But do you see this other one? This other problem? So there's a default route. And that default route sends our traffic out the ETH0 interface. And that should be where our default traffic goes, right? So we'd be able to interact with the outside internet because that traffic would go out to the NAT gateway, get natted, and then go off to the internet and do its thing. But down below, actually, our default route is still there. Ping 4221. Neat. Okay, so the default route is actually still active. That's cool. So yeah, we could actually create a more specific route. IP route 10.0.23. Add. There's 32 via 10.0. Yeah, that works. So that is one way to solve our whole problem. That's actually a really good point. What's the dupes though? I love it. All right, you could write a higher route. Yeah, that's true. But I don't know if you would get dupes. I'm not sure why you would. I'm not sure what your concern with dupes there is. All right, let's see. SSH C1 M01. Oh, that'd be cool, wouldn't it? What is it called? M01. All right. I want to, there we go. C1, Minikube, SSH, minus P, C1, minus N, C1, M01, 2, IP route, add, and 0, 2, 3, /32, dev, ETH0, exit, 3. Spodwenko, exit. All right. Cilium status. Cilium uninstall. That's cool. Cilium install version v1.10.0. kubectl get pods. Problem fixed. That was actually a really good idea. I mean, we're still in an overlap mode, so I'm not totally convinced that we're not going to get bitten still. I mean, let's think it through here. So, The thing that's biting us right now is that DNS is broken on every host. We still have a default route going out toward 10.02x. So when I jump back into that, that might be the problem. All right, cool. We got things running. I want to jump back into 3 here because I want to look at the route table. I bet you number 3's DNS was always working. So we're sending, specifically we're sending 10.020 traffic toward 10.0217. And we're not messing with that one at all. And that one's okay. Yeah, I think we're fine. I think this solves the problem. Because really the only problem, the entire scope of the problem was this IP address. Clever. No, come on. Carlos, why would you do that, Carlos? I didn't make it persistent or anything. I'd have to like actually add a host route or something to make it work. If I reboot these VMs, it's broken forever. Isn't Cilium to help with route propagation? It is, but it isn't there yet. Yeah, I guess that's possible. That'd be kind of fun. Let's see. Let's try that out. Let's see if we can actually get that conflict to work. But before we do that, let's go ahead and explore a little bit more of the Cilium startup stuff. So, boop, boop, boop. Getting started guides. So we did that. Do 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 do. Quick installation. We did the thing. We did that. We did that. Yep. Also did that. Also good. Oh, this is our next one. Cilium connectivity test. This will be a great test because the Cilium connectivity test is actually going to go ahead and connect things up. Mean like people would think you're setting up for prod. Oh, I'm definitely not setting up for prod here. I'm like exploring things. I hope that people never think that when I'm working through an episode, unless I specifically call out that this is going to be like, this is how you would set this stuff up in production, really this is just an exploration to learn and learning it like this. All right. So let's do our Cilium connectivity test. Oh, we didn't conflict. So we did get some 10.02 IP addresses, but we didn't conflict with them. So we're pretty okay. Whoa, hold on. Resolving timeout. Oh, you know what this one is. Anybody want to take a shot? This is kind of a fun idea. It's always DNS. It's coming back. It's doing it to us again. DNS is that valiant foe that will that will get us every single time. I mean, other than DNS. DNS problems. No, it's definitely DNS. But connectivity looks okay, except for the whole DNS thing. So, my friends, how is this getting us to us this time? How is DNS biting us in this particular case? Anybody want to guess? You have a few minutes. You have like a few seconds to guess before I actually go and look at it. It is DNS. Eric! It's always DNS. It's probably DNS. Good to see you, Eric. And Khalid, good to see you. Overlap thing is resolved, yes. The overlap thing is totally resolved. On the nodes. But is it resolved in the overlay network? Is it resolved from the perspective of the pod? Config map, -n, kube system, core DNS. Core DNS 8.8.8.8. So what I want to do is, so let's dig into it a little bit more. Let's actually enunciate what's happening. So our problem is currently that a bunch of tests failed, and they were all the tests that would actually try to resolve DNS. So let's just go ahead and prove that that's broken in the way that we think it is, and we'll do kubectl run it bash image bash, and we'll do rm because I don't really want to keep this one around. APK add curl. Oh, not resolving anything. And that's because cat etsy resolve.conf is 1096.0.10, and that's probably resolvable. But the problem is that if I jump into kubectl exec -ti -n kube system kube DNS recording. Core DNS bash. Oh, really? Is it shut down? Help. Ash? Oh, all right, fine. Well, I was going to jump in there and play with how, like, what the world looks like from inside of the core DNS pod, but it's a secure container, and so we can't. So, what's happening though is that the DNS pod can't actually resolve DNS. It's forwarding to 10.02x, and I believe that packet is still being sent to the wrong place, because from within the DNS pod, which is an overlay pod, right? So its routing table would still be incorrect. Now there's a couple different ways we could fix this. Probably the most sane way is to configure the core DNS configuration so that we forward to something that makes better sense than what we're forwarding to currently. So let's go ahead and do that. kubectl delete pod -n kube system -l k8 app equals kube DNS. Another route would be the other way. But because it's not a thing we could exec into, how would we go about that? That'd be kind of like a pain, right? And so in our case, what we're doing is we're just going to go ahead and drop it. So now I'm going to go ahead and see if our proposed fix actually fixed anything. APK curl, or actually add curl. Hey, we're back in business. All right. Oh, I'm used to having to delete them. Are you saying I don't have to delete them? Because I'm a big believer in just nuking stuff. I'm crazy like that. All right. Shall we do our Cilium connectivity test again? Nice. I like that, Garcia. I also like it when you're like looking at an end-to-end test and an end-to-end test like, we're expecting this to fail. I'm like, good. Like, all green all the time. All right. I love green too. It's one of my favorite colors. Okay, so we got it all working. So next up, I want to look a little bit more into like how like some of the more Cilium things, which are going to be kind of fun. So let's do that. So let's do. Um, so there's other stuff that you can do. So if we do Cilium status, I'll go ahead and ditch this one. So Cilium status says that I've got everything configured and running and stuff, but I don't have Hubble enabled. And I kind of want to turn Hubble on so we can look around and see what that looks like. So with the Cilium CLI, I can do Cilium Hubble enable relay version. I actually learned this one the hard way. V110.0. This is a setting the version of the Hubble relay. Otherwise, it will just deploy. It'll deploy like the older version of Hubble relay. And then I have this other flag UI. And what this command line, what this string will do, is it will deploy the Cilium Hubble relay, which gives us some like really cool observability tools into what's happening, and we can actually like run that same test and actually see like layer 4 visibility on that kind of stuff. And then I'm also going to deploy the UI so that we can actually go and look at it in the UI. kubectl get pods dash n kube system. Part of this process is rebooting the Cilium pods, and I haven't actually looked into why that is yet, but I am kind of curious. So it's one of those things that I definitely want to look into. And it might be related to the fact that like there's a new. I'm not sure exactly. I'm not gonna make conjecture here because I actually want to know explicitly why the Cilium pods have to be restarted. At the moment, Cilium CLI installs 19x by default. We'll bump this to 110. I do want the latest and greatest. I'm crazy like that. All right, here we go. Okay, so we got this thing up and running. So now other convenience features inside of the Cilium thing, it's got completion, which I'm a sucker for, you know. It's also got an upgrade functionality, the uninstall functionality, the install functionality that we've already just kind of been playing with, but it has this Hubble functionality as well. And we were just using the Hubble functionality to install Hubble, the Hubble relay, and to go ahead and configure the UI as well. Now that we have those things running, we can do things like Hubble port forward. I'm going to background that process. And this is basically just doing kubectl proxy in the background. And then if we go back to our quick start docs, the next thing it's going, we're kind of working our, whoops, hold on, ding. Okay, there we go. So we've done our connectivity test. The next thing I wanted to do is kind of do this inspecting network flows CLI piece. But I'm just going to do it with my bash app or with the connectivity test. I'm not going to get into this part of it yet because we've kind of been at this for about an hour and I want to cut it off here in about another maybe 10 or 15 minutes. And then I'll be back in 2 weeks to do this all again or to dig more into it. But down below here, we have this Hubble observe command. And so that's what I want to play with. I want to play with that Hubble observe command and actually show this part of it working. So let's just play with that real quick, and then we're probably going to call it for the day. So what I've done is I've done Cilium Hubble port forward, because the Hubble process isn't exposed. I haven't exposed it like using Minikube as a service or anything. And so I need to actually get to it somehow. So what I've done right here with this Hubble port forward is effectively kubekettle port forward service Hubble relay and basically mapped 4245 from the service and also back down to my local host, right? And so now on my local machine, I'm listening on port 425 and 4245, and my connections will just get tunneled into the Kubernetes cluster into that Hubble relay. Now that I have that, I can grab the Hubble CLI and do a Hubble status, and we can see our connectivity is working. We see 3 of 3 nodes. We can see our connection is going to localhost. The health check is okay. We can see flows going through the system, which is pretty exciting. And we can see 23 flows per second are happening. If we do Hubble observe namespace Cilium test -F. So now we're actually watching the Cilium namespace for traffic. And what we're looking at right at the moment is all just like layer 4 stuff. So we're seeing like the acknowledgement packets, we're seeing like, you know, fins and all kinds of TCP flags, and this is just traffic moving back and forth, which is pretty cool. And if we go back to our quick start docs, we had a way of even further filtering it so that we could look for the drops. Verdict dropped. So I want to see that here, right? Verdict. So we're following the output. We're not seeing any drop packets at the moment. Everything is going through just fine. So let's go ahead and generate some drop packets. Cilium connectivity test. And we should be able to see the drop packet. Oh, there we go. So there's our policy enforcing the Cilium drop packets. And we're seeing ICMP v4, and you can actually distinguish between ICMP v4 and ICMP v6 drop packets. Pretty cool. So our connectivity test is still passing, but we're able to actually like observe those drops. And so like you can imagine, like if we were troubleshooting our DNS problems again that we were just running into, like observability like this could actually come in really handy to be able to see, like, you know what, that DNS packet is timing out, or you know, we can kind of dig into that sort of a view. Yeah, that would be cool. All right. What if I did bunk? Grip. Is that better? So this is from the command. This is from the terminal interface, and so we can see things this way. But like some people are visual learners, and let's look at what that would look like. Hubble UI. So we'll do Cilium Hubble UI. This is the open source product, and what this will do is it's doing another kubekettle port forward, and it's port forwarding us to the Hubble UI. And it assumes that I have open, which is a Mac command. And I do not have that on my Linux machine. Because that's not how we roll around here. You know what I'm saying? All right, so let's see. Boop. And then, no, that's not that one. Let's drag this over here. Nope. Let's drag it over here. Okay, so here's the Hubble UI. And we go to our Cilium test configuration. Then we can see information about what's being connected to. And these are basically the end-to-end connectivity tests that are happening, right? And if I wanted to see those dropped packets in a visual way, I could see exactly which packets are being dropped and who's making those calls. Now, what's interesting about this is that in the connectivity test, it's actually implementing a network policy that improves the visibility even more than just layer 4, right? So by default, when you're looking at this, you're only going to see layer 4. Is the packet allowed or dropped? You're going to see the verdict, you're going to see that sort of stuff. But if you want to see more information about it, then you actually have to create a network policy or annotate pods in such a way that we can actually expose like layer 7 protocol visibility, and then we can do even more interesting stuff like catching for protocol ICMP or catching for protocol HTTP. I want to dig into that one next time. I definitely want to play more with this and kind of like show how a lot of this functionality works. But yeah, I'd love to kind of like do more and more of that kind of stuff. And actually, I'm personally very excited. Like, I think this from a networking perspective is mind-blowing, right? But I think that what we're doing, because we're still, again, operating at that eBPF layer, what we can do to expose more of what's happening at that process layer is even more exciting. So, quick sneak peek into how it's going. But we have things like filtering. We can do all kinds of interesting stuff like in viewing and how all of this works. So that is what I wanted to cover today. I am looking forward to the next session. We will dig more into this. We'll also probably find some other eBPF stuff that's happening in the ecosystem and start playing with those things. I'd love to do like a Eli 5 on eBPF and kind of dig more into things like how it works and how to conceptualize it in your head. But this was my first session, so I was kind of taking it easy through content, although we had fun chasing routing problems and fun chasing DNS problems. Thank you very much. Conjoined triangles of success. You're killing me, Noel. I hope that you all got something out of this session. I know it was a fun one for me because, you know, it's like it definitely further validates it's always DNS, right? In this case, it was fascinating because it was always DNS except for when it wasn't. Our problem was actually a routing problem, not a DNS problem, but still very entertaining. And I'm hoping that was useful and kind of like, you know, you've got a few more tools that you can stick in your pocket. This particular problem, the overlay, the fact that there is an overlap in IP networking is a problem that I've seen a number of times when working with people and trying to understand like how they've actually managed to mess up the configuration of their cluster. So that's a real thing. And the troubleshooting scenario that I was just showing you there and took you through will come in handy at some point, especially if you're like building ephemeral clusters or you're looking at multiple clusters or you haven't really given it a good think about exactly how you want to configure this. But yeah, thank you. I will see you in 2 weeks, this time on this channel, and I look forward to, you know, walking this path with you all. So thank you all very much, and I'll see you next time.